Hello everyone. So we're going to go through the notes for Target 2B. Since I can't be there in class with you today, I'm just going to do on a video. You'll copy them on your note sheet and then work on some practice on your own. So Target 2B is not super different from Target 2A that we've been working on the past couple days. So for Target 2B, it wants you to evaluate the domain of a function and understand how function notation can be applied to real-world problems. So we've done function notation already before, and we know how to find a domain of functions, so now we're just going to apply them to some real-world problems. So we have this warm-up problem right here, over here. So it says warm-up, f of x equals x plus 1 to the second power minus 3. So it tells you write the steps for finding the output of this function. So that is what we're going to do. We're going to write the steps of how we would go from our input to our output. So remember, to find the steps, we got to go with our order of operations. So please excuse parentheses, exponents, multiplication and division, and then addition and subtraction. So we have to figure out the order in which we're going to do this. So first one is parentheses. We have parentheses in this one. So the first thing we would have to do is whatever is inside the parentheses, which is to take the number and add 1. So we've done our parentheses. The next step. So we had parentheses, we've done our parentheses, we have an exponent. So we have to do the exponent first. So next we multiply it by itself. Right, and our third and final step is to do that subtraction, because that comes last. So we would take whatever number we have and subtract 3. So this one isn't actually giving you any inputs. So all you're doing is writing the steps of how to take your input to get your output. So same thing for this next one, right? It says write the steps for finding the output of the function. So we look at our order of operations. We look at our parentheses, don't have any, and then exponents is next. We do have an exponent, so that's the thing we're going to do first. We're going to take the number and put it to the third power, right? Which means multiply it by itself 3 times. So the number times the number times the number. So no parentheses, so we don't have to worry about that. There was exponents, we did that. Then we go to multiplication and division, right? Because the 3 is in front of the x, that tells us that we have multiplication. So the next step is to multiply that number that we get from doing our exponent and then take it and multiply it by 3. Once we've done that, we have our last step. So we've done our exponent, we've done our multiplication, and our last step is to do our subtraction. So now we're going to go into finding some real world problems, kind of how we did at the very last problem of our last packet. We're identifying domain and range, a reasonable domain and range for certain situations. So our first situation, sound travels about 294 meters per second, right? So we take that sentence, sound travels about 294 meters per second, right? There's about 3 feet in a meter. So that's saying that sound travels almost 1,000 feet per second. So it gives you your function, the function d of t equals 294t. So that's just saying 294 meters times however much time you have. So the d of t is in meters and the sound is t in seconds. So it's asking you, how far does sound travel in 9 seconds? So to figure that out, we're going to take our function, right? It tells us d of t equals 294t. So that tells us take 294 meters and multiply it however much time we have. So if we're looking for 9 seconds, right, so instead of t, we're looking for a specific time, which is 9. So for d of 9, we would do 294 and multiply it by 9. And that's going to tell us how far sound travels in 9 seconds, which is 2,646 meters. I don't know why the multiplication symbol, there we go, that's the multiplication symbol. So now it says to identify the domain. So our domain in this situation is time, and our range is our distance. So in this situation, it just said sound travels at about 294 meters per second, right? So it's not really giving you a distinct starting point or ending point. So we know we use the letter T for time, right? So time could start at 0. You could start at the very beginning, and it goes on forever and ever. So that symbol is that infinity symbol. So time is never ending. So it starts at 0 and it goes on forever. So the way that that works with distance, right? Your d of t, right? If you go no time, right, you're going to go no distance. But if you go an infinite amount of time, you're also going to go an infinite amount of distance, right? If time is going on forever, sound will also be going on forever and ever. Right, so in the problem that we did yesterday, it talked about the granola bars, but it told you that there were only 300 granola bars that they bought. So that gave you an ending point on your domain for this situation, which then gave you an ending point on your range. With this one, right, it doesn't tell you. It asks you how far it travels after 9 seconds, but that doesn't tell you that time stops after 9 seconds. That's just a question to go with the problem. It doesn't give you an ending point, so we use infinity. Alright, so we've got our next problem. Gravity pulls objects to the earth at a rate of 9.8 meters per second. The function h of t equals 9.8 t gives the height in meters that travels in t seconds. So it's asking if you drop a pencil and it hits the ground after 1.5 seconds, how high up was the pencil when you dropped it? So we have to use our function. And this is telling us an amount of time, so that's telling you something that we have to take that 1.5 and we have to put it instead of t. So to find the height after 1.5 seconds, we would take 9.8 and multiply it by 1.5. And that is going to give us 14.7. So that means it told you the pencil, it hit the ground in 1.5 seconds. That means it started at a height of 14.7 meters. There's about 3 feet in every meter. So we're looking at that pencil was held up at a height of 45-ish feet. So 45 feet, like that's way taller than definitely the first, just from floor to ceiling of the first floor. It's taller than probably about all 3 stories combined. So that's dropping a pencil from a pretty high situation. So we're identifying the domain and range. So for this one, again, the domain is time and the range is height. So with this one, yes, technically time goes on forever, but the height at which you can drop something, that kind of has a limit to it. So as long as it says, right, it says identify a reasonable range for this situation. So as long as your domain and range are reasonable, if you can make an argument for them in this situation, then you're fine. So if we wanted to say that time could go from 0 to 5 seconds, right, we just have to figure out what that means in order for with the height. It's supposed to be a T. Right, so we're matching the minimum, right? The minimum is going to go with the minimum, and the maximum is going to go with the maximum. So in this situation, the minimum was 0, so if it took no time, it was already on the ground. There's no height. But if it took 5 seconds, then we have to figure out what height it's at. So we take that 9.8 and we multiply it by the time 5. And that tells us that it was at a height of 49 meters. 49 meters is like 150 feet, so it's taller than a roller coaster. So it's just up to you. As long as you can identify a reasonable domain and range, then you're good. For the last one, we could use infinity because talking about sound can travel over light years, right? Sometimes when a star bursts, the star bursts and then we don't even hear it until years later because it has so much distance to cover that it takes so long. So it really is an infinite amount of time. But with dropping a pencil on the ground, right, we can't drop a pencil from one part of space to another part of space because gravity only works on Earth. So we have to worry about things that are a little bit more of a smaller situation. Okay, so last problem we have here is let f at t be the number of people in millions who owned a tablet t years after 2012. So t years after 2012. So that means, right, if it was 1 year, it would be 2013, right? Because that's 1 year after 2012. Or if we're looking at 5, that would be 5 years after 2012, so 2017. So that's what it's talking about in t years after 2012, right? And we're looking at the number of people in millions who owned a tablet. So we have to look at this situation right here, right, and figure out what it means. So we know that our input is the number that's inside the parentheses. So the input is 6, right? So that means we're looking at 6 years after 2012. So that would go with 2018. And for output, right, that is the number that's outside of it. So it's saying the function with 6 as an input would give us 25.3 as an output. So we've got your output is 25.3, right? But in terms of the problem, it was the number of people in millions. So you have to make sure we're writing the million that goes with it. And so it wants you to explain the meaning of the following functions. So we take this input and output that we have and turn it into a sentence. So we could say, in 2018, 25.3 million people owned a tablet. Right, so that would be our answer to that one. So you're taking that function that they gave you, the 6 is the input and the 25.3 is the output, but you can't just say input 6, output 25.3. You have to put that in context of the problem. So with the context of the problem, our output was the number of people in millions who owned a tablet, and our input was the certain year after 2012. So we had our input of 6, which meant we were looking at 2018, and the output of 25.3 is telling you that it's going to be 25.3 million. So now you're going to work through this practice section on your own, and when you're finished, there's another page of practice that you are going to do on your own silently. You may not work with partners.